Alright, today what we're going to do is review changing an equation, quadratic equation, that is in standard form, from standard form to vertex form. There, how you're going to do that is by completing the square. There's two purposes for completing the square. One is for solving a quadratic equation, finding where its roots or solutions or x-intercepts. That's one way. Or you can use changing to complete the square by changing from standard form to vertex form. Just a quick reminder, this is quadratic. The reason this is quadratic is because my highest exponent is a 2. This is a quadratic equation, or quadratic function in standard form. Okay, and the reason I know it's a function, well, for a couple of reasons, it's y equals. So it's sometimes a function, and it's going to graph as quadratic, and it should cross twice because there's the highest powers too. So if I want to change this from quadratic to standard form, I'm going to complete the square. However, what one quadratic function looks like in standard vertex form, it looks like this. Where I have an h and a k. My h and k are my vertex. And this is in vertex form, which is it's a lot easier to graph. If it's in this form, if I asked you to find the vertex in standard form, a lot of you would look at me like I was crazy, but needless to say, that is one of the purposes of completing the square. So I'm going to go and try to do a couple examples on how to do this. Alright, so if I have, this is an example, y equals x squared plus 10x minus 15. I'm going to change it, again, this is from standard form to vertex form. How I'm going to do this is by completing the square. One thing I want to go over is my a term in this problem is 1, my b term is 10, and my c term is negative 15. When you're completing the square, one of the things that you have to remember is that the first step needs to be, remember that my a term has to be 1. In this example, since a is equal to 1, I can do my next step. I'm going to isolate my quadratic term and my linear term from my constant. So how I'm going to do that is just, I truly just make some room. And I isolate my x squared and my 10x. Those are, one's a quadratic term, one's a linear term. And I'm going to put those together from my constant. What I have to do here with completing the square is I have to find a new c. And to do that, what I'm going to do is I'm going to take my b term, divide it by 2, and square it. If you had me in Algebra 2, we had a little piece of paper with a b in it, and we took the b, divided by 2, and squared it. So when we were doing this, I could remember, and most people can remember how to find a new c. Well, in this example, b is 2, b is 10, and divided by 2 and squared. So I have 10 divided by 2, which is 5, and squared. So my new c is going to be 25. But in math, you can't randomly just add 25 to one side of an equation. You can add 0 all day long. So if I want to add 25 inside the parentheses, I have to subtract the 25 as well. If in Algebra 2, if you had a hard time with this, most of you remembered to add this c, but you forgot to subtract the c. You knew how to do this, but where your error was right here. You can't add a number to an equation, but you can add 0 all day long. Alright, so I found a new c. Now what I'm going to do next is I have what's inside my parentheses. I have x squared plus 10x minus 25, and I can factor that really quickly because what's inside the parentheses is a perfect square trinomial. So how this is going to factor is x plus 5 squared, or x plus 5 times x plus 5. So I factored what was inside my parentheses, but what I have to do here is I got to combine those, what's outside the parentheses, which happens to be minus 40. In a different color. Okay. Now, what I have here is I have the same factor of x plus 5 times x plus 5. Well, how many x plus 5s there are? There's 2 of them. So I can write it as x plus 5 squared minus 40. Now, these two equations are the same exact thing. What's in here, this right here, is in standard quadratic function in standard form, and this is the same exact quadratic function in a different form. If you were to graph them, they would graph the same exact way. If you were to multiply this one out, you should get this. It means like if you FOIL it, or multiply it out, distribute it out, and combine your like terms, you should get the same thing. These two functions are the same exact. But once if it's in this form, in vertex form, my vertex I would be able to find very easily. When we're doing a math, the vertex is very important. It tells us lots of things, the maximum and the minimum. But the vertex in this problem would be negative 5, negative 40. And I've run out of room. Let me see if I can't. The vertex is negative 5, negative 40. Okay, this is my h, and that's my k. Again, remind you that the h is counterintuitive if it's inside the parentheses with the x. Okay, so let's do another example that is a little bit harder. Okay, here's an example of a quadratic function that has an a term, something other than 1. Okay, so because my first step in this quadratic function, my highest exponent is 2, and my first step, what I'm going to do, again, is isolate my quadratic term and my linear term for my constant. Okay, so what I'm going to do here is I have to find a new c right here. But to do that, for completing the square, your a term always has to be 1. But the a term in this problem is not 1, it is 3. So our first step is to factor out that leading coefficient. And I'm going to factor it out just from the first 2 terms. I'm only going to factor it out of the quadratic term and the linear term. I don't have to worry about the c or the constant. I'm going to leave it isolated. So my first step is I'm going to take my a term and I'm going to factor it out. Okay, that means I'm going to factor out 3 from 3x squared. When I take, in other words, I can take my 3 and divide it into 3x squared, and what I'll have left over is x squared. I need to divide or factor out, which means the same thing, the 3 from my 12x, and what's left over is 4x. Okay, I'm going to leave that alone. Okay, now what I need to do is find a new c. And I'm going to find a new c using this b. The b is my 4. So I'm going to take the 4, because that's the b term right here. Take my 4 divided by 2 squared. Well, 4 divided by 2 is 2. 2 squared is 4. So I'm going to add 4 here. Again, when I find a new c, it's always going to be positive. So I've got a new c, so I can't just add a number to an equation, but I can subtract or add a 0. So if I add 4 here, I got to subtract 4. But I'm not just adding 1, 4. I have actually 3 of them, so I have to multiply 3 times that 4. Okay, because I'm not just adding 4 inside the parentheses, I'm adding 3 of them. Okay, so what I have here, to make it a little bit neater, 3 times x plus 4x plus 4, and I'm going to add or combine the 11 minus 12, which is negative 1. Because 3 times 4 is 12, 11 minus 12 is negative 1. Now what I want to do here is factor this, what's inside my parentheses. So y equals, this is x plus 2, finger, x plus 2 times x plus 2 minus 1. Okay, when we factor this, most of you have learned this way. X plus 2, there's 2 of them, so I can write it x plus 2 squared minus 1. Again, this right here in this term, it's kind of a little cheat, shortcut. This term will always be your b divided by 2, but can't really skip a step because you got to know what your new c is. Okay, so on a side note, the whole purpose of this is to find my vertex, and the vertex for this is negative 2, negative 1. And so that's where this is opening up, so my lowest point is negative 2, negative 1. Now I know you have some homework problems like this. There's an example 6 in your book, which I can do. I'll add another slide just for you, those of you that want to do another one. But for your homework in section 2.1 is there's some complete the square and describe the graph of each function. So those questions are from 33 to 38. But of course, some in your book, they make it a little bit harder, and they have to rearrange the forms. But to rearrange it, it needs to be in standard form, which is your A terms first. So I'm going to do an example 6 from your, well, I would do an example 6, but it's really simple how to do that one. Not much different than what I just did. Mostly the same exact problem I just did. So actually this example is example 6 from your book. But I can quickly do a homework problem. Number 36. So I'm going to pause. Okay, this is example 36 in your homework on page 183. And the reason I wanted to do this one is because several reasons. Y equals, they give you this problem, 8 plus 2x minus x squared. Okay, the examples I did, they needed to be in standard form. This is not in standard form. It is mixed up. To be in standard form, you need to have your quadratic term first, then your linear term, then your constant. So let me rearrange this in standard form. Now that I have it in standard form, then I can start completing the square, which I'm going to, first step, is isolate the c. Then I'm going to factor out my a term, which is in this problem is negative 1, so I have to factor out negative 1. Now that I have a b, and this is my b term is negative 2, I'm going to take that, divide it by 2, and square it. So I'm going to take negative 2, divided by 2, and square it. Write it down here. Going kind of quickly. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So I'm going to add 1 here. If I'm going to add 1, I have to subtract the 1, because I can add 0. I can't just randomly add 1. But again, I need to multiply it by this. So I'm going to multiply it by negative 1. Okay, so now I'm going to make it a little bit neater. Y equals negative 1, x squared minus 2x plus 1 plus 8 minus, the reason it was minus, was because I was adding c and then subtracting the c. So it was minus 1 times a negative 1. Okay, so now what I need to do is simplify, make it a little bit easier and cleaner. So I have y equals negative 1. I can factor inside my parentheses x minus 1 squared. This is going to be negative 1 times negative 1 is a positive 1. 1 plus 8 is 9. So my vertex in this problem is going to be 1, 9. Okay, and my A value is negative 1. That means it's opening down. So hopefully that helped. I think that was probably one of the harder problems in your homework, but I'm thinking you can handle it. All right, good luck.